Here we consider fractions and why the multiplication of them works the way that it does. Before we dig into that, we need to consider a few foundational issues, and those are what a fraction is and what the rectangular area model of multiplication is, because that's the model we'll be using. So an important aspect of working with fractions is understanding what your unit is. Each one of these squares here represents one unit. When I look at the fraction 1/2, I'm considering this square to be one whole. It's been cut into two pieces, which is what gives me the denominator, and one of those pieces is shaded, and that gives the numerator. So I have 1/2. Whereas here, we've taken the unit, which is our square, and we've cut that into 4 equal pieces, and that's our denominator. We're talking about fourths here. 3 of these pieces have been shaded, therefore our numerator is 3. And you can check with these other fractions that they are working the same way. We've got 2 pieces shaded here, there's the numerator, and it's 2 of 5 equal pieces. Similarly here, 2 pieces shaded, that's the numerator, which is the number of pieces we're counting, and the denominator is the number of equal pieces that the unit has been cut into. There are many models for multiplication, but the one that works particularly well for explaining why multiplying fractions works the way it does is the rectangular area model. So as an example, in order to multiply 2 times 3, I can create a rectangle with a height of 2 and a width of 3. And in order to find the result of this multiplication, I determine the area. In other words, I count the units that are inside, the square units in there. And this is 1, 2, 3, 4, 5, 6. So this is 2 times 3 is equal to 6. And I have a fuller video on the rectangular area model of multiplication. I'll link that in the description below. So we're going to do 2 problems involving multiplication with fractions. And we're going to attempt to understand why the procedure works the way that it does. So when you multiply fractions, it's top times top, bottom times bottom. So the result here should be 1 times 3, 3 on the top, 2 times 4, 8 on the bottom, so we'll get 3/8. Over here we're going to get 4/15. So let's do that using our fraction overlays. So 1/2, here is our fraction representing 1/2. Okay, we talked about that earlier and why that represents 1/2. And then I'm going to take the fraction that represents 3/4 and I'm going to overlay that. Remembering that the square is a single unit and the number of pieces a square has been cut up into is our denominator, we notice that we have 1, 2, 3, 4, 5, 6, 7, 8. So here we are talking about eighths. And it's 2 times 4 equals 8 because we've got 2 this way and 4 this way. 2 by 4, or 2 times 4, gives us 8. And then we want to look at which pieces are double shaded. And I notice that I have 1, 2, 3 pieces that are being considered in each of these shapes. So that's a total of 3. 1 times 3 is 3. And so we can see that the result is 3/8. So looking at another example, we'll take our fraction that represents 2/3. There it is. And then working with the same unit square, we're going to overlay that with the representation of 2/5. Remembering that the denominator comes from how many equal pieces the unit was cut up into. Well, the unit was cut into 3 pieces this way and 5 pieces this way for a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we get 3 times 5 is equal to 15 in the denominator. And then for the numerator, how many pieces we're considering? Well, those are the pieces that are double shaded. It's got kind of the dotted shading and also the diagonal line shading. And that's going to be 1, 2, 3, 4. which is 2 by 2, or 2 times 2. So the number of pieces the entire unit is cut into comes from our denominator, that's the 3 by 5. The numerator is how many pieces we are considering, that is the 2 by 2, which gives us the 4. And this supports the fact that multiplication of fractions has a rule which says we multiply top times top, bottom times bottom, gives us our result. And here we can see why that is.